So, good day once again. So, this time, our topic we're gonna tackle today is inclined plane. So, we will discuss what an inclined plane is, the different forces acting on an object placed on it, and how we resolve these forces into components, and how we use Newton's second law to analyze the motion. So, do you guys still remember unsay formula sa Newton's second law? Okay, so if not, don't worry kay ma-show ra gyapon nako because of ma-show ra gyapon nako sa ato mga problem solving. So first, what is an inclined plane? So an inclined plane is a flat surface that is tilted at an angle. So instead of moving an object straight upward, an inclined plane allows us to move it along a slope. So the angle of the slope is represented by the Greek letter theta or theta. So the steeper the inclined plane is, the greater the angle. So here are the common examples sa inclined plane. So we have a slide, basta kanang loading platforms, and kaning slope roads or ramps. So as you can see, the common difference is it's in an angle gid siya. Tapos diba if mo go down tag slide diretso og drop. Ay, diretso og drop kundi mo na sa angle. So that is an inclined plane. So here are the forces acting on an inclined plane. So when an object is placed on an inclined plane, like example on a slide, several forces can act on it. So we have gravitational force, we have normal force, and frictional force. So the first is gravitational force or weight, represented by F sub g or F gravity. It always acts vertically downward. So diba most of the time yun na nga ang gravity is straight downwards. While dito sa inclined plane, it is vertically downwards. Tapos don't worry, makita na gyapon nato na sa isa ka diagram na nga unsa itsura ana na vertically downwards atong gravity. So the second one is the normal force, which is represented as N, pero actually it is F sub norm. This is the force exerted by the surface on the object, and it acts perpendicular to the surface. So kaning normal force, it is responsible na nga para siya, diba ang gravitational force, it's pulling the object downwards, pero kaning normal force, it's responsible para dili mo go through gid atong object sa ramp. Let's say ramp ni, tapos ning pull down ang gravity sa object, tapos kaning normal force ning pull up siya para di sa mo go through, di sa mo diretso mulaho sa slope or ramp nato. And here we have sa frictional force, it acts parallel to the surface and opposes the motion. So friction acts along the surface and opposes the object's motion or its tendency to move. So frictional force is responsible para mo-move atong object. So let's say na nga ning go down atong object, pero kaning frictional force, it opposes the motion, so going upwards siya. So now gravity always points straight downwards, but because our object is on a tilted surface, we can make the problem easier by resolving gravity into two components. So diba katong ganihan na slide na nga niingon sa vertically downwards, that's why it's because tilted naman gud atong surface. So to make the problem easier, by resolving gravity into two components, so para mas simple atong problem, i-divide nato ang gravity nato into two components. Diba sa last nako na lesson na nga, if imong force kay it's an angle na agad say components, which is katong diba example angle, tapos na say vertical component and horizontal component. But since light naman po diri kay inclined plane naman ta, we have parallel component and perpendicular component. So the first is parallel component, given by F parallel is equal to mg sine theta. So mg is stands for m times g, or overall overall weight. This component acts down the slope and causes the object to tend to slide downward. So, parallel component is responsible para nanuman atong object ning move. While the second is the perpendicular component. This which is represented as f f parallel is equal to mg cos theta. So where m is equals to mass nato of the object, g is the mg, no, it's not really gravity, it's different, my bad. So g is actually acceleration nato due to gravity, and theta is the angle of the inclined plane. Sorry, it's not actually naanay ko sa Kondo equilibrium, my bad. So this component acts into the surface. So this component acts into the surface. So basically, instead of treating gravity as just one force, we split it into two directions that are easier to analyze, because like katong equilibrium, di ba, kay basta naay diagonal force nagyud say components, which in this case we have parallel component and perpendicular component. Here we can see na nga atong F gravity or atong gravity force is vertically downwards. Tapos here, makita nato ang two components, parallel component, which is here sa downwards, because parallel component is parallel, or meaning it moves along the surface or moves along the it moves along the ramp. Tapos perpendicular component is here. Because here we have our theta. Tapos para ma-visualize nato tarong atong mga forces, we use a free body diagram or FBD. So unsa nang FBD di ay? So a free body diagram is a drawing that shows the forces acting on an object. So here we have gravitational force. It points straight vertically downwards. Here we have kaning red. And we have normal force, which is normal force points perpendicular to the inclined surface. And we have So normal force perpendicular to the surface. If friction is present, the frictional force acts along the surface and opposes the motion. So there are times na atong normal force there is friction present or not. So this diagram helps us identify which force acts parallel and perpendicular to the inclined plane. Thanks, guys. So now let's talk about the normal force on an inclined plane. So the normal force is represented by F sub norm. So is the force exerted by the inclined plane to support the object. It always acts perpendicular or 90 degrees to the surface of the plane. So diba? So normal force, it acts like a support for the object para di sa mo go through sa surface. So in an inclined plane, gravity can be separated into two components, diba? So F parallel and F perpendicular. So the perpendicular component of the gravity is balanced. Okay, so the perpendicular component of gravity is balanced by the normal force. That's why we have, here we go. So we have F norm is equals to F perpendicular is equals to m times g times cos theta. So basically atong F norm, which is kana arrow, o atong F perpendicular, which came from our gravity, balance kini sila. So it equals to m times g times cos theta. So this means that the normal force depends on the object's mass, gravity, and the angle of the inclined plane. So because mass represents m represents mass, g times gravity and times gravity gali. Okay. Okay. So the simplest case is no friction. So for the simplest case, we assume that there is no friction. So for the force perpendicular For the simplest case, we assume there is no friction. For the force perpendicular to the plane, the forces are balanced because the normal plane pushes against the perpendicular component of gravity. So, for the perpendicular to the plane, ang F norm ug ang F perpendicular is is always balanced since ninghelp man og support atong normal force sa atong sa atong perpendicular force ay perpendicular component or F perpendicular. So since they balance each other, the net force in this direction is zero, meaning the object does not accelerate into or away from the surface. So since there are balance and there's no friction involved, so ma-stay put ra gyud atong object. So however, for the force parallel to the plane, the situation is different. So during a part, there is an imbalanced force pulling the object down the slope. This is the parallel component of gravity, which is F net is equals to F perpendicular. Perpendicular equals m times g times sine theta. Tapos using second law, so using Newton's second law, here makita nato, i-substitute ra nato ang F net into this kaning m times g times sine theta tapos over m. So i-cancel out ra nato ni atong mass. All we have left is a times g times a equals g or a equals gravity times sine theta. So in a frictionless inclined plane, the object's acceleration depends on the angle of the slope and gravity. So now let's factor in friction. So nanay in friction involve ani. So when an object slides down an inclined plane, friction acts in the opposite direction of the motion. Diba, like katong as we know na nga opposing direction yun na ang friction. So if the object is sliding down the slope, the frictional force points up the slope. So the frictional force is given by here, which is F friction is equals to mu, which is called the coefficient of friction. It tells us how much friction there is between the object and the surface. So here we have perpendicular to the plane. So just like in the previous example, the forces perpendicular to the plane are balanced. Diba, like basta perpendicular to the plane, it balances due to sa norm. So next na po is so let's skip since na-discuss man nato ning perpendicular to the plane, let us now discuss a parallel to the plane. So for parallel to the plane, which is forces parallel to the plane are unbalanced because we now have friction opposing the object's motion. So kaning parallel plane nato is now unbalanced because nana sa involved na friction. Because friction, of course, is opposing the object's motion. So the component of gravity pulling the object down the slope is F parallel is equals to mg times sine theta. But friction acts upwards, diba? So it is now F friction is equals to mu times mg cos theta. Therefore, the net force is F net is equals to m times g times sine theta minus mu times mg cos theta. Without then use kaning Newton's second law, tapos i-substitute ra nato ning F net and we cancel out the mass. And now we're left with A is equals to g times sine theta minus mu times g times cos theta. So now we have a example. So let us read it. So 3.45 kg object slides down a 28.3 degree inclined plane. Ignore friction. So this is the most simplest case. So fill in all the blanks and determine the acceleration. So first step is we tanaw na to atong given, which is 3.45 kg, diba? And number 2 is pangitaon na to ang overall weight or the F gravity or Fg. So all we have to do is times our mass with gravity. So 3.48 kg. I'm gonna use my calculation. So 3.45 kg times gravity, which is times not gravity, so 9.8. So the answer is 33.8. So next step is pangitaon nato ang parallel kanato pangitaon nato atong parallel force, or so which is all we have to do is times our mass, which is 3.45 kg times grams, our gravity, which is 9.8, times tapos sine, tapos atong theta or degree is 28.3. So we're left with 16 point n sa atong F perpendicular, tapos atong F net, which is the same, which is 16 point n, meaning unbalanced force. Kaya diba atong F parallel is unbalanced or not balanced. So number 5 is kailangan, so all we have to do is substitute nato atong 16.2 ay 16n. So 16n divided by sa atong mass, which is 3.45 ay wala 16.0 divided by 28 3.45, which we are left with which we are left with 4.65 meter per second squared. So next up we have atong pangitanayon nato atong perpendicular force. So i-times nato atong mass, which is once again 3.45 times 9.8, which I think wala 3.45 times 9.8 tapos times cos tapos atong angle, which is 28.3. So the answer is 28.9. And tapos last, since diba sa perpendicular it balances with our F norm, so it is 29.8 gyapon siya, since just remember unsay answer nimo sa imong F perpendicular is the same sa F norm since they balance each other.